Hey guys, I'm Jade. Today is my LeetCode review vlog on the 61st problem, rotate list. We are given the head of a linked list. We have to rotate the list to the right by k places. We're given the example 1 here to understand it easily. We got an input linked list 1, 2, 3, 4, 5 and k is equal to 2, which means we have to rotate the list to the right by 2 places. In the first rotation, we'll move the last node, node 5, to the new head node here, and we'll remove the rest of the nodes 1 step forward, 1 to here, 2 to here, and so on. And for the second rotation, we'll move the last node, node 4, to the new head node, and move the rest of the nodes 1 step forward. So the final output linked list is 4, 5, 1, 2, 3. And node 4 becomes the new head node. Then, let's get started with our intuition to solve the problem. And the keyword is we'll make a circular list and breaking it. Make a circular list and break it. Then, the detail step is we'll traverse the linked list to find its length and the last node. Then we'll connect the last node to the head node to make the list circular. And for the example 1 here, we'll connect the last node, node 5, to the first node, node 1. Then we'll find the new head position by using the length of the list and the given k values. And we have to make k mod n to get the correct and easy values of steps to move from left to right. Then we'll break the circularity at the correct position to form the new rotated list. And for example 1 here, we'll break the connection between node 3 and node 4, and the node 4 would become the new head node. Then let's get started with our intuition to solve the problem. In the first step, we have to handle 3 edge cases, and the code is if the head is equal to null, or the head dot next equals null, which means there's only one node, or the k is equal to 0, which means we don't have to move any node. For these 3 edge cases, we just return the original head node, as we don't have to do any change. In the second step, we'll have to calculate the length of the list and get the last node. Let's create a variable first. Let's say list node, current node, started at head. Then we'll create another variable. Let's call it length, started at 1, because we have already checked the 3 edge cases. And then we'll create a while loop. Let's say the condition is current.next is not equal to null. If so, we have to move the current pointer 1 step forward, and the code is current equals current.next. Then we have to increment the length variable. And out of the while loop, then we have to connect the last node to the head node to make it circular. And code is current.next equals head. Next, we have to calculate the new head position using the modular operation to handle cases where k is greater than the length of the list. And the code is int new head position equals length, subtract the result of k mod length. And many people would ask why we have to make k mod length. This is because if we rotate a linked list of length n by n steps, it could bring every node back to its original position. So when k is greater than the length of the list, which is n, the effective number of rotation steps is the remainder of k mod n. Therefore, we only rotate the linked list to the right by k mod n steps to avoid unnecessary rotations. Then, we have to create another variable. Let's call it new tail pointer. New tail pointer started at head. Next, we'll create a for loop to get the correct new tail position. And code is for int I, iteration pointer started at 0, and I should be less than new head position minus 1. And the reason why we subtract 1 here, it is because we want to get the position of the previous node of the new node, because we have to break the pointer of the previous node, of the new node. So we have to subtract 1 here. And we have to increment I, the iteration pointer after each iteration. And code inside the for loop is we have to make the new tail pointer move 1 step forward. New tail dot next. And out of the for loop, the new head is the next node of the new tail. Let's say list node, new head node equals next new tail. New tail dot next. Then we'll break the circular connection between the new head node and the new tail node to form the new linked list, starting from the new head. And code is very simple. We just make new tail dot next equals null. Then we just return new head node itself. And let's submit the code to check for the correctness. Then let's analyze the time and space complexity. Yes, our code got accepted. So the time complexity, it is big O of n, and n is the number of nodes in the linked list. Furthermore, we traverse the list a couple of times and the time is constant. So the overall time complexity, it is big O of n. And the space complexity, it is big O of 1. This is because we just create several variables here and the number of the variable is constant. So the overall space complexity, it is big O of 1. And this is the end of my LeetCode review vlog on the rotate list problem. And I highly recommend you guys to visit my online GitHub page here, which contains the notes for the top 115 LeetCode problems here. Let's say for this problem, rotate list problem here, you can see the problem description, intuition, Java code with annotations, and the final time and space complexity analysis. You can also visit my online GitHub repository here, which contains the nodes and code to build the online GitHub page here. And I'll put those two links on my YouTube description below. And thank you guys for your watching. I'll see you next time. Bye bye.